There is a pervasive assumption in enterprise architecture today that autonomous AI agents are simply complex software components. The belief is that if you map them correctly, they will fit neatly into standard IT portfolios alongside your existing applications. That assumption fails because it misinterprets the object being governed. Traditional frameworks, like TOGAF, are designed to govern systems that execute deterministic, heavily scripted logic. Agentic systems do not execute pre-written scripts. They exercise judgment. They interpret signals, choose among competing options, and execute actions under partial uncertainty. This diagram shows what happens when you force an autonomous agent into a traditional TOGAF matrix. By placing an agent inside the application domain, the static models fail. The agent's autonomous decisions create unpredictable ripple effects that shatter API boundaries and cross freely into your data and business domains. A static blueprint cannot intervene in a real-time decision. If an agent is granted the authority to act under uncertainty, the architecture must exist where the decision actually happens, at runtime. Bounding autonomy is not a software engineering task. It requires an evolution in the object of enterprise architecture itself. We are no longer architecting systems. We are architecting agency. Traditional enterprise architecture focuses heavily on state transitions. It asks how the entire enterprise landscape should coherently evolve from a baseline state to a target state over time. Agentic architecture asks a different question. It defines what must be structurally true for an autonomous system to behave reliably under real-time conditions. To answer that, this model replaces broad domains with 7 governing primitives: intent, authority, policy, scope, meaning, proof, and effects. These primitives act as constitutional physics. They form a strict boundary wall, structurally defining what an agent can decide. We are shifting from an architecture designed for organized change to an architecture designed to govern bounded emergence. Within those governing primitives, meaning and scope take on a new level of importance. Standard data models and corporate glossaries are far too passive for autonomous actors. Here, 2 agent nodes process the exact same data vector. Lacking a shared semantic model, their output paths diverge sharply, resulting in coordination failure. To fix this, a semantic anchor gate forces the data through a reference definition, aligning their paths into parallel coordination. This introduces the principle of context admissibility. This is an architectural rule dictating the precise contextual information an agent is legally permitted to use when making a choice. By defining what variables are admissible, the architecture prevents an agent from hallucinating scope or pulling in unauthorized external data to justify a rogue action. Shared semantics and rigidly defined context are not optional documentation. They are the non-negotiable preconditions for trustworthy autonomous coordination. Architecture review boards, static compliance standards, and lifecycle planning are effective for human-led teams. They are completely incapable of intercepting a dynamic, unauthorized decision made in milliseconds by a machine. Governance cannot remain an external oversight activity. It must collapse directly into the executable infrastructure. This is the governance spine. A decision signal is intercepted and routed into the runtime control plane. The policy engine annihilates it against constraints. The protocol engine locks it into a valid state pathway. Finally, the effects gateway measures the impact scale before releasing it. Tacit design time blueprints hope a system remains compliant. The runtime control plane actively enforces that compliance at execution time. Architecture ceases to be a passive plan and becomes the structural engine that enforces governability while the system is in motion. A single agent making an isolated decision is rare. Enterprise systems require multiple autonomous entities to interact continuously. Standard business workflows map out predictable, linear steps, but agentic interaction occurs under uncertainty, where not every path is fully prescripted. This requires protocol-governed interaction. A simple API call is no longer enough. Every single handoff between agents must be governed by an explicit contract. Look at this exchange. The entire interaction space is mathematically enclosed by a protocol contract. If an agent attempts an invalid state transition, the boundary instantly rejects the action and forces a strict recovery loop. Without strict protocol constraints enforcing every handoff, dynamic coordination between agents rapidly degrades into unstable emergence. Standard enterprise frameworks struggle with behavioral accountability. Relying on basic application logs to reconstruct complex machine reasoning is a forensic nightmare. Agentic architecture introduces a strict mandate. It is not enough that a system functions. Its underlying logic must be entirely reconstructible and legally justified. As an action leaves the effects gateway, an identical, immutable passport is simultaneously forged and deposited into an audit and replay ledger. This passport captures the precise context, policy evaluation, and authority state, projecting a replayable history of the agent's logic. This enforces a core architectural obligation: one event, one passport, one producer of record. Traditional frameworks govern the design of the architecture. Agentic architecture produces undeniable, replayable evidence of the behavior itself. The introduction of a runtime control plane does not make traditional enterprise architecture obsolete. The relationship is layered, not adversarial. Organizations still require TOGAF for capability mapping, portfolio prioritization, and business alignment. The standard TOGAF domains form the structural base of the enterprise stack. The agentic architecture, the governance spine, control plane, and proof ledgers, locks directly on top. A clear gap separates the two. The bottom governs deterministic execution, while the top governs authorized judgment. When software is granted authority to operate under uncertainty and create real-world effects, standard enterprise architecture remains necessary, but is no longer sufficient. TOGAF provides the method for governing enterprise architecture. These structural primitives provide the method for governing enterprise agency.